Hey everyone, welcome back to net.tutsplus.com. Today we're going to be looking at regular expressions. So more specifically, we'll be reviewing positive and negative look-aheads and look-behinds. So first, we're going to figure out what the heck are those, and second, you're going to learn why they're good for performance and how to use them and why you would actually use them in your regular expression testing. So let's get started. I'm going to be using a tool at gskinner.com/regexr, regular expression. What's nice about this tool is it offers live testing of your regular expressions. And then secondly, it offers within the sidebar a legend of sorts that allows you, if you quickly forget what a specific symbol or character refers to, it'll show you. So what we're going to be working here with is positive and negative look-behinds, and that's these four right here. So first, let's create some gibberish to work with. John, Bon, Con, Don, Lon. Okay, so let's say we want to match an O. So first we have to be careful. Do you want to match a lowercase o or a uppercase O? You have to be specific with regular expressions. In this case, I want a lowercase o. However, if it doesn't matter, within your regular expression, you can just add the I modifier. Or in this case, I can hit ignore case, and that means it'll match a lowercase o or an uppercase o. Secondly, if I want to continue matching even after the first match, you can apply the G. In some languages, the G modifier, and that means global. In this case, you see it will continue matching. And just to show that we can also do an uppercase O, you'll find that that matches as well. But if we turn off ignore case, that no longer matches. Okay, so let's say we want to match an O, but I only want to match an O as long as it's preceded by a J. Okay? Well, how could you do that? Well, first, you might think, okay, we'll just prepend a J. Now this seemingly works, but here's the problem. Now you aren't matching an O anymore. You're matching J-O. You're matching Joe. So what happens if you only need to match that O? Okay, well, how could you do that? The way you do it is with a look behind. So a look behind means, let's go ahead and look at it right now. A positive look behind matches a group before your main expression. However, it does not include that group within the result, and that's what we want. We only want O to be in the result, but we want to look behind and make sure that there's a J that precedes the O before we match it. So let's try it out. I can create a negative look behind by putting it in parens, and we do question mark, less than sign, equals, and then our symbol. So in this case, my symbol is going to be just the letter J. So now you can see that we only matched the O just as long as we looked behind and we checked to see that there was a J there. So in this case, it did it for each one, and it found there was a J there, and it found there was a J here. But in these cases, those were not preceded by a J, so they were not matched. Okay, so what if in reverse you decide, okay, I want to match an O just as long as the preceding character is not a J. In that case, you would use a negative look behind, and it's pretty much the same syntax. The only difference is you change that equal sign to a bang. And now it's going to match everything, every O, just as long as it's not preceded by a J. And you want to make sure that's going to look for the the most recent character. So if we do something like that, it's still going to match, because even though it is preceded by a J, it's not immediately preceded by that J. So that's something you want to keep in mind. So if I add a J in front, that will cease to match at that point, because at that point it will be preceded by a J. And in this case, with a negative look behind, we're not matching. So you're looking behind the character, and if you find whatever symbol you pass, in this case the letter J, it will not match it. If you want it to match, use a positive look behind. It's kind of confusing, but you'll get your head around it very quickly. So on the contrary, we can do look ahead, and it's pretty much the exact same thing. So if I want to match an O just as long as the character that comes after the O is an E. In that case, again, we could do the E, but then you're matching OE. You're no longer matching O, and that's probably not what you need. So again, to do a positive look ahead, you do question mark equals. So the only difference between a look behind and a look ahead is this right here. So that's positive look ahead. This is positive look behind. So in this case, we're looking for an E. And there you go. It goes through all of these because we do have global turned on. And it's only going to match the O's that precede the letter E. So let's say you want to precede the letter period or a period, something like that. Okay, well, be careful about this. You could do period. And how come that's matching everything? Because the period refers to any character. So if I go to the top, it's kind of like the universal character. It matches anything except for a line break. So if you literally mean look for a period at the end, make sure you escape it. And this means, no, we're talking specifically about a period. And in that case, it will only match the period. But remember, zoom in there, we're only matching the O in this case. We're not matching the period. So when could you actually use this? You'll use it all the time. Think, whenever you're matching something, but you don't need to capture that group, you're only using that group for the sake of matching and ensuring that it is a match, make sure you use lookaheads and lookbehinds. So let's take an example. Let's say we want to match a Twitter username. So we have NetTouch, but we also want to be careful because we could use the @ symbol, but then it would also, if we do it incorrectly, match email addresses too that contain the @ symbol. So I'm just going to add a bunch of stuff here, a bunch of different formattings. Okay, so now let's try matching these. So what our goal here is we want to match this username. So you can imagine with whether it's PHP or JavaScript. By the way, JavaScript, you kind of have to get clever to use a look ahead and a look behind. There's some links that I'll add to this tutorial that you can refer to. But in PHP or other languages, it shouldn't be a problem. Okay, so our goal is to match this username only. We do not want to match this. We do not want to match this. We only want to match NetTouch. Okay, so the first step is always remember, if you can be specific, always be specific. So if you can, just match NetTouch and you're done. Of course, only in rare situations can you be that specific. Usually, maybe you're matching any username. So in that case, you need to be more flexible. But if you can be specific, definitely do so. Okay, so let's figure it out. We know a username will begin with an @ symbol. We can be sure of that, right? Okay. Next, we want to match, how could we do this? Well, we could do a \W. That's going to refer to a word character. So a word character is anything that's alphanumeric, so letters and numbers, and the underscore. So here, notice we're only selecting the first letter. Why not the rest? And remember, this is only selecting a single character. If we want to select more than one, let's do plus, and that means match one or more of the preceding token. So it looks good on the username, but there are a couple problems here. One, well, we're matching this part of an email address, and we certainly don't want to match that. And two, this username has a dash in it, and that is not covered within a word character. All right. So, and then again, we're matching a portion of this email address. So maybe we can be different. Let's think, what if we could match anything? So let's say, let's match anything just as long as it's not a space. So how can you match any character that is not a space? Well, we know that \S will match a space. So, and if you didn't know that, you know it now. So let's go to the top. The \S matches any white space character, and that'll also match a tab. So one thing worth noting with regular expressions, and it's why it makes it easier to learn. It's very confusing when you first get started, but then you kind of learn the language much like learning Vim, the code editor Vim. So if you make the S capital, it's going to reverse it. So while lowercase s matches any space, uppercase S will match anything that is not a space, as you can see here. The same is true for a word character. So \W matches any word character. Uppercase W matches anything that is not a word character. So in this case, if I do \S, you can see there it has tons of matches because we do have global turned on. So for example, if I do a plus, that's going to match every single character just as long as it's not a space. So if I turn off global, it's going to match that username. Okay, so now we're getting that whole username. So we're being very flexible here. If they wanted, they could do @net something like that, and that's still going to match. So what you have to decide is that okay? Maybe if you're doing some kind of database scouring, you don't want to accept that. But in this case, I think it might be okay. But we still have a problem here is, well, first let's prepend the @ symbol because we know a username begins with the @ symbol. All right, so now we're matching every username that we have here. So we're getting close, but we're still matching a portion of an email address. Shoot. How can we fix this? Okay, well, what is the difference between this email address and this username? I see two. One of them is the email address contains a period, okay, and the other one is a username will always proceed a space, or in this case, it'll be at the beginning of the line. So why don't we use that one? Why don't we say only match a username, only match this sequence, as long as it proceeds a space or it's at the beginning of the line like we have here. So let's try that. In this case, we're going to use a look behind. So we know that a look behind is $, equals, and we're going to do \s, which refers to a space. So that seemingly fixes it. Not quite, but almost. So now we're not matching this space. Remember, that is the difference here. If I do \s, that will achieve the same thing, but the only difference is you're matching that space, and we don't want to match a space. We're only using the space as a parameter of sorts to make sure that we are finding the right thing. So if you need that s, but you're not matching it, use a look behind, like so. Well, we have one more problem here. It's not matching this one at the beginning, and that's because there is no space that precedes this. So if I add a space, it'll match immediately. So what you can do is you can use the OR. So I can say a \s, so match that sequence of characters only on the condition that you look behind and you find either a space, like we do here, 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 and here, or, and we can use an OR with the pipe, or it's at the beginning of the string that you're looking at. So you can reference the beginning and the end of a string with the caret symbol right there, and if I hover over it, matches the beginning of a string, and the $ symbol, which is the opposite, it'll match the end of the string. So I'm going to get rid of that. And now we've matched everything we want to. So it seems so complicated, especially if you're new to regular expressions, but once you decode it, it's really not. You'll quickly learn, okay, whenever you see this sequence, it's not gibberish, it's a positive look behind. And we're looking behind for either a space or the beginning of a string. And then this is what we're actually matching. We're matching the @ symbol followed by any sequence of letters that's not a space, and one or more of them. So as soon as it gets to a space, this no longer matches, in which case it fails and it stops. Okay. So that is look behinds. Let's reverse it now. So we've done this one. Now we want to match just this email address, but not match any usernames. Okay, well, we can do this. Let's first begin by looking for, you can be as specific as you want here. So let's say we want to match a word character. Or let's go in here and we're going to say we're going to match a word character, and there can be underscores or dashes, something like that. And we're going to look for one or more of them. So let's see what that does right now. That's going to match all of these, but we're not matching the @ symbol. So make sure you allow for that one too. Now, email regular expressions can be really long, so I don't want to go into that too much. We're going to be somewhat general here. And then you can also see that it's not matching the period. So let's also make sure that a period is acceptable as well. And I'm going to escape that to make sure that it knows I'm referring to an actual period and not the period symbol, which refers to any character. But then we have this problem where it seems like we're matching too much. So we know that every email address will end in some extension, like jeff@jeff.com or jeff@jeff.edu or jeff@jeff.org, anything like that. Usually it's going to be between 2 and 4 characters. So what you could do here is look for those. Why don't we change this up and we'll say look for a word character and look for one or more of those, and then you're going to come to an @ symbol, and then you're going to look for, and you know what, we can remove this character class because it's not necessary. Then we're going to look for any more word characters until you get to a period. And then you're going to look for any set of word characters, but between 2 and 4. So what this means is match a word character, and then when you precede it with curly braces, the first one will be the minimum number to find, and the second one will be the maximum. So for example, if I were to change this to something really long, it's no longer going to match. But we still have this problem where it does match as much as it can. So what you can do here is add a word boundary. So let's look for \v. There you go. Matches a word boundary position such as white space at the beginning or ending of a string. So that's what we want here. We only want to match. We don't want to match as much as we can. So let's make sure that we add a word boundary at the end. And if you wanted, you could even add it at the beginning. So this is a very, very basic form of matching an email address. You would honestly need to be a little more specific. They can get really long. And then there's lots of weird issues with different languages and extensions and things like that. But this will be a good very first start. So now that we know how to match an email address in a very quick and half-assed way, what if we just want to break it down and match the actual site name, tutsplus.com? Let's figure out how to do that. Well, let's go back and let's search for the @ symbol, and then followed by, again, let's search for the capital S to match anything that's not a space. And again, we're going to match the usernames, and we're also going to match this part. So we're getting there. Now, the first thing I notice is I don't want to match the @ symbol. All I want is tutsplus.com. So in that case, whenever that occurs, let's make sure that we use a look behind. So we're going to use question mark, less than sign, equal @. And that's going to look for an @ sign, but it's not actually going to be included within the match, as you can see right there. And then secondly, we're still matching these usernames here. So what makes this one different from this? Well, there is a period, and there's spaces. So you could do a space again, but you're going to get the same thing here, where this is followed by a space as well. The only way that would work would be if maybe the username was at the end, in which case that would not match. Something like that. And then you have the problem where you're matching a space, and you only are using the space to make sure it matches. So in that case, if you wanted, you would use a positive look ahead. That way the space is not being matched, but you're still looking for it to make sure that you match the preceding token. That's not what we're going to do here though. So I'm going to get rid of this, and then I'm going to look for anything that's not a space until I get to a period. That way I can match everything I can until you get to the period, and then we're going to do that extension again of a word character of 2 and 4. Or if we wanted to be more specific, we could say something like A to Z, 2 to 4, something like that. That way, this is pretty rock solid. It would probably need more testing, but to give you a basic idea of how you would make a distinction between net@tutsplus.com from @nettouch. So what we've done here is we've used a positive look, and I wish they wouldn't say look ahead when it's not. They're using a positive look behind to make sure there's an @ symbol there, and then we match any character as long as it's not a space until we get to a period. So as long as you get to a period, we're going to stop matching that. And then finally, we look for the period, and the period designates that it's probably an email, and there's going to be an extension that follows. And then we look for 2, a minimum of 2, so that could, match AU or something, but it also could match a 3-letter extension like com or the edu, and then even 4 if there are 4-letter extensions. It really just depends. You can get some weird email addresses, and that's why if you're actually matching an email, do a Google search, because you'll find some long strings that are rock solid that you would want to use instead. Okay, so that's mostly what I wanted to cover today. We looked at positive look-aheads, positive negative look-aheads, positive look behinds, and negative look behinds. So you'll get a lot of use out of these. You'll find tons of different ways that they can be taken advantage of in your web applications. So my name's Jeffrey Waite. Thank you for being a member of NetTuts. If you haven't already, please subscribe to us. We appreciate it, and allows us to bring you more tips, tutorials, and screencasts. I'll see you guys later. Bye.